Hello everyone and welcome to the next session of Digital Redays. My name is Silas Zorn and I will moderate this webinar today. Yeah, we are very pleased that you took the time to participate in our next session. The topic today is LoRa interesting facts about the sub-GHz radio technology. Our speaker today is Ravindra Singh, who is working as a product manager in the field of iSmart at Würth Elektronik ISOs. Before we start with the webinar, I would like to point out one thing. You will be mute during the webinar today. This means that you cannot ask questions about with your microphone, but after the presentation you have the chance to ask your questions anytime via the Q&A tool. You can find us this below on the right side. Today's webinar will be about 30 minutes long. After that, we will answer your questions in a short Q&A session. If we are unable to answer all your questions within this time, we will answer them via email after the session in the next days. Last information for you. You will all receive the link to the recording and to the presentation also in the next days. And now I wish you an exciting and interesting webinar. And now I give it the ball to Ravindra.
So first, let's see the sort of agenda which we are trying to cover today. So first, we will see the two different terms, LoRa and LoRaWAN, what they are and how they are different. And then we will see the kind of IoT options available in the market and how we can choose the right IoT connectivity for the application. And then we will see the advantages of LoRaWAN technologies and frequency bands in which LoRa technologies can be deployed or can be used. Then we'll see the broader level network architecture of LoRaWAN and what are all LoRaWAN deployment options. Then we'll see the important aspect in which your devices can be configured, called LoRaWAN classes, either class A, B, or C. What are all those classes and how they are different from each other. Then we'll talk about the Daphnis. Daphnis is our upcoming product in LoRaWAN technologies. So we'll talk about the key features only about the Daphnis. And finally, of course, the LoRaWAN applications, which will be covered by question and answers. So what LoRa and LoRaWAN are, that is the first question which comes in mind. So LoRa is kind of a modulation scheme through which your data is transmitted in RF format. So what it means is that LoRa is being defined, LoRa modulation scheme is defined by Semtech, and it covers all the aspects which are needed for the PHY level or the physical level layer of the protocol stack. Then the LoRaWAN are the specifications which are developed on top of the LoRa modulation scheme. And those LoRaWAN specifications are mainly maintained and covered by LoRa Alliance. So LoRa Alliance determines the kind of using same physical layer, but they have developed the kind of MAC layer on top of which we can develop the applications. So LoRaWAN defines kind of classes, different classes, different type of classes, how to use them, and what type of security features to be enabled in those when data is being transmitted from your end node to the network server. So all those details are covered by LoRaWAN specifications, which are defined by LoRa Alliance. So now the next question comes is that there are multiple options for your sort of IoT connectivity. So how to choose the right connectivity? So in broader level, if you'll see from this graph, those are divided into different parts. One is the short range and low data rate kind of IoT connectivity solutions like NFC, Zigbee, Bluetooth. Wi-Fi though offers the higher data rates, but still the range is not it's not meant for the long range. For the long range, we have other options called the cellular technologies like legacy technologies, LT, CATM, LT and 5G. Those technologies are good for long range, but you have to remember one thing, that those are the legacy technologies and they are not optimized for the power consumption. So then 3GPP came up with different technologies called LT-CATM and NB-IoT. Those two technologies are designed mainly for IoT kind of devices, and they are mainly optimized for the power consumption. They can provide you lower to medium data rates along with the long range, but they operate into the license spectrum. What it means is that when network operators buys the license frequency bands from the government, then they deploy the network on those frequency bands. And then when you go and use those network operators, you have to pay the fees for the network operators or the tariff to use those frequency bands. While the other hand, the LoRa, if you'll see, it can offer from low to medium data rates along with the long range, and it mainly operates it into the unlicensed spectrum. What it means is that uh, for using this technology, you do not have to pay any fee for the operator or the government to use those frequency spectrum. So all these yellow bubble or the technologies are mainly for operates into the unlicensed spectrum, while the cellular technologies, which are mainly in the red color, are operates into the licensed spectrum. While if you'll see the for long range and very high data rates, of course, you can always go for the satellite kind of communication. So what you have to remember is that when you are choosing the IoT connectivity, you have to consider the coverage in which area or the region your device is deployed, and how much or how long data, how long that device can send the data, and what is the data rate for those IoT devices. Either it is for short low data rate, or it is for mid data rate, or it is for high data rate. And also you have to consider is the power consumption, because each technology has its own advantages and disadvantages. So LoRa is the complementary to the existing IoT communication technologies, which enables to use the low to medium data rates in unlicensed frequency spectrum. Okay, so now we'll see the advantages of LoRaWAN technologies. As I have already covered that LoRaWAN is the low power, it consumes very less power. So it is mainly useful for the low power consumption kind of applications or the battery powered applications. Long range, LoRa stands for long range. It offers the coverage in longer range, and it mainly operates into the license free spectrum, or we'll see the later which are all those frequency bands available for deploying the LoRaWAN. It offers better indoor coverage, and you can choose either you can have your own deployment as a private network. You can deploy your private network, or you can choose the public deployment if there is already available network from the network operators. Thanks to the downlink data which LoRa offers. So because of that, firmware update over the air is also possible for the LoRa devices. And it offers the end-to-end security. What it means is that when end device sends the data, it encrypts that data, and this data can be only decrypted either at the application server or the network server. It offers the geolocation functionality, means that network server can determine your device location. So as we are talking about that, it can be deployed in the license-free sub-gigahertz radio frequency. Here I have tried to capture some few of the frequency bands which are mainly used in different countries or the regions. Let's say in EU, we have is the called EU 868 widely used frequency band, which is the frequency range is 863 up to 870 megahertz. And the other band which is mainly used in EU is the EU 433, and its frequency range is from 433 up to 434 megahertz. Like in USA, the well-known name is US 915. That means the frequency range which it has is the 902 up to 928 megahertz. Same in China, there are different options available to deploy the LoRaWAN. The main two bands which are CN 779 up to 787 and CN 470 up to 510. In Australia, we have AU 915 up to 928 megahertz frequency bands. And in Japan, we have is AS 923, means the frequency range is 920.6 up to 928. So all these details are available into the regional parameters file, which is available onto the LoRa Alliance .org. What it means is that, as I told that this LoRa Alliance is the one which defines the specifications for LoRaWAN, and those regional parameter details are also available on those um, on those websites. Yeah. So you can check in your country what are all frequency bands in which the LoRaWAN can be deployed. So all the list of the countries and the corresponding frequency bands are listed in that PDF file. As you can see that all the frequency bands which are available are within the sub-gigahertz, means below the 1 gigahertz. That means low frequency means longer range, and the longer range stands for LoRa. Now, I'll try to explain the LoRaWAN network architecture on broader level. So we'll see this LoRaWAN networks are mainly deployed in a star of stars topology. What it means is that your IoT devices, or which is also called as the end nodes or the sensor nodes, like pet tracking, smoke alarm, water meters, trash container, vending machine, gas monitoring, all those devices are equipped with these sensors, and those sensors are generating the data, and that data will be transmitted using LoRa technology. So your LoRa module is also been equipped or been embedded inside those devices to send those data using LoRaWAN technology. So these devices will transmit those generated data to the nearby gateways or the concentrators. And these gateways, what they will do is they are just to take this data from those devices and add some metadata on top of that, like your signal strength of the device, RSSI, and signal to noise ratio, plus some sort of arrival time. So along with this data plus some metadata, they will use the backhaul, like either the Ethernet or any of the cellular technologies like LTE or the 3G, and this gateway will forward this data to the network server. So this network server, also known as the core network, this is the one which always determines this data, removes the duplicates, and this also helps in the geolocation of the device. And then finally, this your application servers are connected onto this network server. So network server is the main component here, which has all the intelligence about the protocol. So, and if you'll see, the data which is being sent from these end nodes is encrypted, and this can be only decrypted at the application server. So your data which is being generated from this end node or the sensor node is end-to-end secure, and it can be only decrypted at your application server. Now, you have three different LoRaWAN network deployment options. Either you can have your own private network deployment. Of course, this requires your own deploying the gateways and managing those gateways. The second option is the public network deployments. So in few countries, the network operators or some private operators already have the network infrastructure for LoRaWAN. So first you have to check if in your area where you want to deploy your devices, if the coverage is already covered by any of the public network operator, then you can choose that operator. And the third option is the LoRaWAN network or hybrid LoRaWAN networks, where you can have kind of your private as well as some public coverage. So this kind of last option, hybrid LoRaWAN networks, allows customers to move between the public and private networks. And this can be suitable for kind of use cases involving the asset tracking. What it means is that, let's say your device is moving from one region or to another region. In that case, of course, if you have your own private network, you can not cover the whole country or the whole area where your device is moving. In that case, you can have your own private network for the area where your devices are deployed, and while they are moving, you can use the public network options, because they will have more kind of coverage as compared to if you want to deploy your own network. Now, LoRaWAN has decided or has defined three different type of classes. What it means is that you can configure your device either as a class B, C, class A, B, or C. Class A is the mandatory, which is minimum device can be configured, or at least your device should support the class A kind of configurations. So what it means is that when your device can send data anytime in the uplink direction, so whenever device has the data to be sent to the network server, it wakes up and it transmits the data uplink transmission. And when it does the uplink transmission, at the same time, it also opens two different receiving windows. So what these receiving window does is that they are providing the opportunity for the network server to send the downlink data in that these two, RX1 and RX2. And network server can send only when only in these two opportunities. So let's say once network server has sent the downlink data in RX1, then RX2 is not available for that network server to send the data. If it is missed to send the data in RX1, then only it can send into the RX2 data. And this is the lowest power consumption device, because here network your device is not always listening for the downlink messages. That means it is saving the power. It only allows network to send the data when it is transmitting something in the uplink direction. It means it also adds more kind of latency. So you have to decide whether your device can afford the latency, because it's the lowest power consumption class. The class B kind of devices are similar to what we have in class A. Only one advantage here is that in between also the network server can send some downlink data. So what it means is that the device and the network server agrees upon that for the ping slots or the downlink opportunities on which data can be sent to the class B type of devices. So of course, because device has to wake up in between to listen to the downlink servers, to listen to the downlink uh, channels, it consumes more data, more power consumption as compared to class A devices. But also it reduces the latency, because in that case your network already knows it when to send the when the next opportunity to send the data is available. while the class C type of devices are the kind of always on devices. What it means is that your device will always be listening for the downlink messages, irrespective of whether it's transmitting uplink or not. So let's say example here, the uplink transmission is done. Device has sent some data to the in the uplink direction, and it has opened the RX1 and RX2 two opportunities for the network server to send the downlink data. And the time difference between uplink and the RX1, if you'll see, in that also the device is listening. That is called the RXC. That means receiving opportunity in C type of devices. So what it means is that, and when RX1 is enabled or it's already listening on the RX1, it will close the RXC. And then again, there's a difference between RX1 and RX2. At that time, it will again open the opportunity for in case of RXC. And once RX2 is closed, it is again opening the RXC. What it means is that device will always be able to listen in the downlink. So network server can send downlink data at any point of time. Of course, since your device is always listening to the downlink data, it costs in terms of current consumption. So these kind of devices are mainly where you do not care much about the um, power consumption, but you care about more about the latency, or you need some downlink data in real time applications. So the localization with LoRa, what in general, whenever you want to see the location of the device, what happens is that, like in GPS or in Wi-Fi access point searching or beacon in Bluetooth, in those cases, your device search itself. That means it is searching using either the satellite systems, and once it finds its location, it transmits using different RF technologies. But in LoRa, it is different. What is happening here is that that intelligence is not with the device is only sending its data to the gateways. And when gateways receives those data, they add some metadata like RSSI and SNR and time of arrival. And those metadata along with the data reaches to the network server. And network server has that intelligence to calculate that where the device is located. So this is the main difference here. It adds many advantages, of course, because you are not buying any kind of GPS module or any kind of GPS chipset, which is extra cost. In this case, you are not buying anything, but at the same time, it also has some disadvantage because those GPS kind of locations are very accuracy. In terms of accuracy, you cannot expect similar kind of accuracy in these localization with the LoRa. And here, since network operator, network server is determining the location of your device, then at least 3 gateways should be transmitting the information about that device to the network server. So if it is less than 3 gateways which are sending the data of certain device, then network server cannot determine the location of that device. At least 3 the 3 gateways should be minimum transmitting the information. Okay, so now we'll talk about the key features of our LoRa upcoming product called Daphnis 1. So if we'll see the dimensions, we have lowest or the smallest module available, 15 by 16 into 3 mm. And we are this LoRaWAN module supports the latest specification from LoRaWAN, which is 1.0.4. And also, if we'll see the LoRaWAN classes, we support all class A, class B, and class 3. So you can configure in any of these classes your device. And the first module which we are planning as will support only the EU 868. So it means we are only supporting mainly the first Europe region for Daphnis, and maximum power transmission is 14 dBm requirements. We are fulfilling that requirement, and we'll see the lowest power consumption in terms of when it is in deep sleep. That means it is neither listening to the downlink nor it is transmitting in the uplink. While it, in that case, the current consumption is very low, is 65 nanoampere. While it is doing the current consumption, while it is receiving and downlink, it is close to 7 milliampere, and in transmission, current consumption is 25 milliampere, and operating voltage is 2 volt to 3.6 volt. And of course, this is all the draft values because this product is not yet in market. So these some values may change when final we will release the final product. So let's see some of the applications where LoRaWAN technologies can be used. So this is livestock monitoring. We'll see this belt in neck of this cow or the buffalo. What it has is that it has one node or the sensor node which has different sort of which collects different sort of information, and that information is being transmitted using the LoRaWAN technologies. And here you have two possibilities. In case this area in which you want to monitor those livestock or those animals, if you already have the coverage from some of the operators, you can directly go and get the sign the contract with those operators, and you will get the direct access of those technologies. In case that is not available, because generally those kind of mm, big areas you will have is the outside of cities or some villages, remote areas mainly. In that case, you can have your own LoRaWAN kind of network. You can deploy your own network where you can have your own gateways where you have to monitor all those gateways. So what in that case, you will have complete control of all the information which you want to receive, either its location or its kind of health of the animal. Whatever the data is being generated through those sensors, it can be sent using these LoRaWAN technologies over the air to the gateways and then your network server or the application server. Same goes here, connected lightings. So it could be a warehouse, or it could be office, or any big infrastructure where you want to monitor the lightings remotely. In that case, those lightings are equipped with the LoRaWAN module or the technology, and you can remotely control those lights. Whenever you don't need them, you can switch it off or switch it on, or you can do partially also. Let's say but you want to just switch on few lights, and those rest of you can switch off the light based on the outside how the sun is. So all those remote control you can do using this LoRaWAN technologies. And of course, it has both the options. Either you can have your own network deployment, or you can choose if already available from any of the network operator. Again, another interesting example is the smart farming, where you can have your own network deployment, and these kind of sensor nodes which you can which will be taking the data from these uh, trees or small plants, like humidity or its temperature inside that room. All that information can be generated through those sensors, and this data can be sent using those LoRaWAN technologies to the network server or the application server, where you can monitor and keep track of your farming or smart farming. And good thing is that since you will have the access of that data, you can closely monitor the growth of the plants or the farming. Yeah. Another intelligent irrigation is a very good application where kind of a smart agriculture application where your those sensor data is collecting the information about your soil or the land in which the irrigation is needed. So based on those parameters, you can always have those connectivity and smart monitoring of those devices so that you can open the water or irrigation whenever it's needed, and when it's not needed you can control remotely or you can monitor everything remotely. So in summary, now we know there are many ways to send the data to the cloud. Either it can be sent using any of the low data rate and low range kind of solutions like Zigbee, NFC, Wi-Fi, Bluetooth, and or you can use is the long range with medium to higher data rates, or you can go for the cellular kind of connectivities, but you have to pay for the fee for those kind of options. Then LoRaWAN network architecture, as I have told, that the end nodes generate the data, and this data is being sent to the network server. In between, gateways are deployed. And you know what to do with the different LoRaWAN classes, like we have class A, B, and C. And what is those classes, the difference between class A, class B, and class C, and when to configure which class. And you'll see, you also know now the advantages of LoRaWAN networks and some of the examples. Of course, these are not limited to these applications, but these are just kind of some examples where LoRaWAN technologies can be used. Thank you for your attention, and I hope that you learned something new to make the business. Now we are welcome for any questions or Q&A session. Silas?
Hi, so now, thank you, Ravindra, for the interesting presentation. So now we come to the questions, to your questions. Yeah, first question: is there any airtime restriction to the transmitted data from the IoT device and upload firmware data?
Okay, so thanks. It's a very interesting question. Actually, because these frequency bands which I talked about, on which LoRaWAN works, are the free frequency bands. So in that case, there should be some regulatory body which should regulate the use of those frequency bands. So what happens is that different countries have their own sort of regulations. Like in Europe, if we'll see in 868 megahertz band, they have is the kind of duty cycle. So what it means is that your device cannot send the data more than 1.1% of the time. So in rest of the time, it should be sleeping while sending the while sending the data is allowed on only the 0.1% of the time. So each country has its own regulations. Like in Japan, we have listen before talk, LBT. So before transmitting the data, you have to monitor that channel or the frequency. If there is something already or other devices are transmitting, you should wait till you get the opportunity to transmit on that frequency band. So what it means is that every country has its own set of regulations on which the data can be transmitted or in uplink direction. Yeah.
Okay, thank you. Next question. Hi, what types of modulation are used in LoRa? What are the features of these modulation types in comparison with LBA or and others? Thank you.
Okay, so those information about the modulations, as I told, is the kind of LoRa modulation and FSK modulation. These are the two modulations which are used by the LoRaWAN technology. Of course, these are defined by the Semtech in their LoRa modulation document. And when you are choosing the different type of spreading factor or SF factor, it depends on, so the data rate depends on the spreading factor and the bandwidth in which the data needs to be transmitted. And all those information are already available into the LoRaWAN or the LoRaWAN specification or LoRa specification from the Semtech. Yeah.
Okay, next question. Where we can find the information about frequency bands used for LoRa WAN in different countries or the regions?
Okay, so what you can do is that, as I have told, that all these details are available on LoRa Alliance website as well as on Semtech, because those are called as the parameters or the regional parameters PDF. You can search for it in the LoRa Alliance and website, and you will find complete list of the countries and what are all network frequency bands can be used on those countries, and what is the regulations to use those frequency bands. All that information is available on the websites.
Okay, thank you. Last question. How robust is LoRa in sense of RF, and what are the maximal ranges?
Okay, so the range and actually it depends on to that how many devices are configured and how many are already, and plus because these frequency bands are very free frequency bands, so all that depends on how many devices are already using that frequency bands and how much bandwidth is remaining to be used on that frequency bands. So I cannot straightforward answer this question, but it depends on actual the coverage of in that particular region where the devices are deployed. Yeah.
Okay, thank you. Now we are finished with our session. Yeah, thank you very much, Ravindra, for the interesting presentation, and thank you very much for your all attention. We hope you enjoyed it, and yeah, we hopefully see you all in the next session of Digital V-Days. Thank you and good afternoon. Bye bye.